Hello everyone. Here the question says, a particle of mass m is confined in two-dimensional infinite square. Will the potential of side A? So we are going to keep a particle of mass m in a box in a square, two-dimensional infinite square. The length is going to be infinite. Okay. Here the potential of a side is going to be A. So potential is going to be A. Okay, this is the important thing you have to understand. So potential is going to be A here. The Eigen's energy of a particle in a given state is, so this is going to be a equation, Eigen's equation. Whenever a quantized charge, sorry, a mass of a particle or any particle which is going to be quantized in a box is going to be contained an energy. This is E is equal to, we know this energy, E is equal to n square pi square h bar square. We know that h bar, what is meant by h bar? H is going to be the Planck's constant, but h bar is going to be, yes, what is meant by h bar? I am writing here, h bar refers to, is equal to the Planck's constant divided by 2 pi is said to be h bar, right? This is the, it is also a constant, right? So if we know this, and let's move to the next thing here, n square pi square h bar square divided by, yes, 2 m a square. Here the length is, the potential is going to be A, that's why the potential is given as A, that's why we are using A here, A square. If it is the L, so we will be using L here. So this is the actual equation, the question. Okay, I'm changing the color. Okay, so here we are going to compare these two equations. So this equation need to be compared with this thing. So since they are told that it is a two-dimensional, so it's going to consist of x-axis and the y-axis. So I am going to write in the form of in this equation in this form of two-dimensional. So I'm going to write in the two-dimensional. So where we get, so I will be writing here. So just follow the mouse point. Okay, so if it is a two-dimensional, so E x of y, x comma y is going to be equal to, so here n in the x-axis square plus n in the y-axis. So this is not z, actually this is x, y-axis square. Okay, this is going to be written in the place of n. So the remaining is as it is, pi square h bar square divided by 2 m. Here the length is given as, the potential of side is given as a square. Okay, from this, yes, from this you can able to get it. So by comparing these two equations, so these two equations, what are the things said to be constant? So Eigen's equation, we know that Eigen's equation is nothing but A is an operator, psi of x is an operand, psi of x is an operand, which is equal to lambda is the product of this thing, and operand will be repeating as it is, psi of x. So this is known as the Eigen's equation. So in this, in this equation you can able to notice that this thing is going to be common and this thing is going to be, yes, common, right? So this is going to be the product as per the question. This is going to be the operator which is going to be used here, right? So this is going to be the operator used here. The same thing by comparing these two equations, yes, the psi is going to be common for both. What is going to be common for both is this thing. So I'm just circling here. So this is common and this is common. You can able to notice that. Okay, this is common in the both equations. So according to the Eigen's principle, we are going to Eigen's value. We are going to find the Eigen's value. Then what is the remaining thing? So what are the remaining thing need to be written? Okay, what are the remaining things? I'm just using orange color. The remaining thing is 25, and here the remaining thing is n of x square plus n of y square by 2. So the remaining thing, I am just using the remaining thing right here. So 25, which is going to be, by comparing this equation you can able to get it, n of x square plus n of y square by 2. So when you multiplying 2 on both sides, you can able to get this equation as 50 is equal to n of x square plus n of y square. We have to find the quadrants. We have to find the quadrants. Here n is said to be the wave function. If there is a single wave, here, so you can able to understand this is n is equal to 1. If there is two wave here, okay, this is a 2, so this is the wave function is going to be 2 in this case, in this wave, whereas in this the wave function is 3 inside the box, 1 2 3, right? We get to know that. And wave function is 4 when 1 2 3 and 4. Okay, sorry, I'm just left more gap for this. The wavelength is going to just change here, so sorry for that. Now we have to find the wave function, the x-axis and the y-axis. Right here the quadrants, we have to find the quadrants. To find the quadrants, I'm just moving to the next page. Yes, so what is the equation we got finally is 50 is equal to n of x square plus n of y square. Okay, we just solve this using the Schrodinger equation. We just derive this formula using Schrodinger wave equation. Yes, Schrodinger equation. So I'm just saying the example for the Eisen's principle in uh, the following sessions. Okay, I'm just showing that in the following section. Okay, here now. So to find that, we have to just multiply with 1 comma 1. So we know that this is the x-axis, this is y-axis. So by substituting here, if I'm just substituting, what other things can be possible is, if 5 5s are 25, right? 5 plus 5, 25, 25 is equal to 50. Yes, 25 into. So the x can be 5 and the y can be 5. The y-axis can be 5. This is quadrant, first quadrant to solve this. So we have to find, okay, what we have to find is the state is, so how many quadrants can be taken place in the state. This is going to be the first one. So the next possibilities is going to be 7 square plus 1 square. As by substituting n of x is 7, n of y is 1, you can able to get, this is going to be 49 plus 1 is going to be 50. This is going to be satisfied. So then the next thing is going to be 7 comma 1. Okay, the following thing, the same thing can be opposite. So 1 square plus 7 square. So this is going to be also 50, which is going to be satisfied this equation. So three equations can be satisfied here. That is 1 comma 7. So these are the three equations which is going to be satisfied with our equation. So here 3 degenerates can be possible. Here the state is 3 degenerates. So where is the option 3 folds degenerate is option B is the correct answer for this question. So I am just showing the agent's energy equation. Normally agent's value, agent's agent's equation, agent's value can be written as, yes, this is the operator, this is the, normally, sorry, I'm just drawn the bracket here. So this is going to be the psi is the operand, psi of x is going to be the operand, which is going to be equal to the value which is going to be provided by this operators and operand, and the operand should be repeated again. So this is the important thing, criteria you have to see here. And by seeing this, I will show you an example for this equation. Example for this equation, just we see the differentiation of e of I will be saying 3x by dx. Here I'm showing that the operator is going to be d by d of x, and the psi is going to be, yes, I'm just using another any other color so for the to vary this thing. So psi is going to be, okay, psi of x is going to be exponential power e of x. Okay, I'm just continuing this equation which is going to give rise to, okay, e power 3x, okay, d of 3x by dx. Okay, d of 3x can be written as here, is going to be n is going to be 0. So yes, d of 3x can be written as 3 of d by dx can be written as x power n is equal to here 1. So 1s are 3. So finally we get the value as, so instead of I am writing this thing, I am just erasing and writing the direct value. Direct value is 3 here. Okay, now look at this very carefully, so the psi which is equal to e power, exponential power e of x. Now the psi is exponential 3 of x. What is the product we got from this thing is this, the lambda is the product, that is 3 in this case. So there are many explanations can be done by this equation, so I'm just sure that, and thank you for giving me, watching the complete video.